more depth on savings plans and investments. So here's another formula. And this is called our savings plan formula. And this is when we are making regular payments into savings plans. And that means like each month or some given amount of time you are inputting the same amount of money into the savings plan itself. And so A is your accumulated balance, so how much money you have in your savings account. PMT stands for regular payment amount, so that's how much you're depositing on a regular basis. Your APR is still your annual percentage rate as a decimal. N is the number of payment periods per year, and Y is the number of years. So don't worry, you don't need to memorize this formula. You just have to be able to plug in numbers and use it. But I'm also going to show you a function of your calculator where actually it has this formula auto filled for you. All right. So I'm going to show you one time how you can use that by hand, and then we're just going to jump to our calculator. So it says use the savings plan formula to calculate the balance after 6 months for an APR of 12% and monthly payments of $100. All right. So once again, the savings plan formula is just amount equals 1 plus your APR over N to the NY minus 1, whoops, over your APR over N. All right, so 1 plus, my APR is 0.12. Remember, N is the number of payment periods per year. So if I'm making monthly payments, how many payment periods am I making in a year? In the chat. Good, 12. So 0.12 over 12. And this is to the power of N times Y. Here's another question. So we already know that N is 12. If Y is the number of years, in this case, how many years am I saving for? What value should I plug in for Y in this example if I want the balance after 6 months? Yeah, 1/2 or 0.5. Perfect. So 0.5. Then we have minus 1 over my APR 0.12 over N, which is over 12. All right, this goes into our calculator. And we're going to get the accumulated balance after 6 months. So we're going to enter it all at once, so you just need to be careful with parentheses. All right, so I'm going to do 2 open parentheses, then we'll go 1 plus 0.12 divided by 12. Great. to the power of 12 times 0.5. Okay, minus 1. Divided by, open parentheses again, 0.12 over 12. Close. And then it's important that you do a check for sanity. Oh, I'm sorry, Naomi. Yeah, I totally missed what you, I missed that part of the formula. Sorry, guys. There's a payment. Thank you. I didn't even include our payment. So you're supposed to multiply your monthly payment at the beginning of this. So times 100. There we go. So I need this whole thing times 100. So here's, if you didn't know this, you can always do an insert, which is second delete, and that'll put it before where your cursor is. There we go. Sorry, I realized I just wrote on my iPad, but I wasn't sharing that with you. Sorry. So I included this, which I missed in the first one. We're supposed to have our payment at the beginning as a multiplier. All right. So what I was about to say, you should always do a check for sanity at the end of this. So if we're depositing $100 a month for 6 months, we know we should have at least $600 in our account at the end of all this. But you're also accumulating interest, so you're going to expect it to be more than $600. Now, if your answer comes out to be $1 million, probably something's up. So if you could make $1 million by depositing $100 for 6 months, we'd all be millionaires. But if it comes out below $600, you also know something's up. So 615.20 is our answer. And that answer makes sense, right? Slightly more than 600 because we're accruing interest each month as we make these deposits because we have a annual percentage rate of 12%. All right, so that was 615.20. And there is our answer. So that's how we can do it by hand. Using the formula. You'll be allowed those formulas for the exam and for the quiz. But there's also something in your calculator that has all of these finance formulas pre-programmed into it. And that thing is called the TVM solver. TVM stands for Time Value Money Solver. And all the TI 83s and 84s come pre-programmed with it. So that's going to be in apps. You're going to go into finance. So I clicked apps, which is right next to the math button. We're going to click finance. And it's the first option. It's your TVM solver. All right, we're going to define all these entries. Sorry, I'm just copying them down. So I want you to write these down too, because we will define what these mean, and you'll want to know what these mean. All right. So I'm totally fine if you just don't use the formula here and you use the TVM solver in your calculator instead on a quiz or a test. But the work I would need you to show is you're just going to list out what all the inputs are on your TVM solver when you use it. So first thing I'm going to do is tell you what these mean. All right, the capital N is total number of payments. So I'm calling a payment just a payment now. It can be for a loan or a savings plan. So if it's a payment for a savings plan, what I really mean is how often are you depositing into your savings account? So I need the total number of deposits you're going to make. I is just your APR, your interest rate. But notice that here there's a little percentage symbol after it. So you are actually entering it as a percent, not as a decimal. PV stands for present value. How much money is currently in the account, or how much do you currently owe on the loan, depending on what type of financial calculation we're making. In this section, we're going to be talking about savings account. So present value is how much is currently in the account. PMT is your payment, so your deposit amount. FV is future value. P/Y is payments per year. C/Y is compounding per year. So how many times does it compound in a year? Okay. So that's the definition of each one of those. To actually use the TVM solver, here's what we're going to do. So the total number, I'm going to redo this problem, but in the TVM solver. So for N, the total number of payments that I'm going to put into my account for 6 months is just 6, right? So I'm making 6 deposits. My interest rate is 12%. The present value, so before we start making monthly deposits, the present value is 0. The payment amount is 100. I'm making $100 deposits. The future value, this is the thing that I'm going to solve for. Payments per year. We're making monthly deposits, so that's 12. And compounding per year should always match this, okay? So we're going to assume that the savings account is compounding monthly. So I'm also going to put 12. All right, so let me go back to the calculator and I'll input those. So I'll leave the future value as 0 for now. There we go. It auto-fills compounding per year to match payments per year. Yeah, so you're just going to leave future value unknown. That's the thing we want to solve for, and this is the way we do it. You're just going to leave payment at end. But you can see that above enter, you have that solve command, and it's green. So I need to go alpha, because that'll access those green commands. And then I'll hit enter. And that'll solve it. Okay, so this is coming out as negative 615.20. And here's the reason. Anytime you're taking money out of your pocket, you should really enter it as negative. So my payments are money that I'm taking out of my paycheck to put into my savings account. So really, instead of positive 100, I should enter it as negative 100. And then if I do alpha solve, you see I get the positive account balance of $615.20 in my account. All right, so that's how you use the time value money solver in your calculator. So I think there's another example. We can kind of continue to use that. There we go. And so that's how you would set it up. This is the work you would need to show in your problem set or on a quiz or a test if you were just going to use the TVM solver instead of using the formula you're given. All right, couple definitions. An annuity is any series of equal regular payments. So usually like a retirement fund will be an annuity where you have like automated a certain amount to come out of your paycheck every time you receive one. And go into your savings account. Oh, hold on, I just saw a question. When you press solve, it didn't, all right, sorry, definitions. An ordinary annuity is the savings plan in which payments are made at the end of each month. And an annuity due is a plan where payments are made at the beginning of each period. In this class, we're mostly going to be concerned with ordinary annuities, which is why I said just keep the payment, that part of your calculator, keep it at end. All right, the future value of an annuity is the accumulated amount at some future date, and the present value is generally a lump sum deposit that's not the same amount that you're going to be depositing every month, right? So this is common in like a loan or a mortgage. If you're buying a house, you'll generally have to put some amount of money down first, and then you'll pay a different amount monthly after that. All right, so here's a fun example where I'll teach you how you can figure out what you need to do to save up for something you want. So let's say you'd like to retire 25 years from now, and you'd want to have a retirement fund from which you can draw an income of $50,000 per year forever. How can we do it? And we'll assume a constant APR of 7%. So your savings account has an APR of 7%. So the idea here is that we want a large enough balance in our account so that it basically makes $50,000 a year in interest alone. And then we can just take that $50,000 out. And while we're spending that $50,000, there's still enough money in the account so that the interest it accumulates over that year will be an additional $50,000. So every year we take out $50,000 and the account itself earns it back in interest in that year. And then we can take out another $50,000 and just continue doing this indefinitely, right? All right, the first thing we're going to do is figure out how much total money needs to be in the account so that it's earning $50,000 a year. So I'm going to go .07, which is my interest rate as a decimal, of some amount so of your account balance, you need to equal that $50,000. And so what we want to do is solve for the account balance. So I can turn this into a multiplication problem. 0.07 times, let's just call it A, equals 50,000. So A equals 50,000 divided by 0.07. All right, so this comes out to $714,285.71. All right, so what we figured out is that if we had that amount in an account, then it would, and we just let it sit, then it would earn $50,000 over a 1-year period just on interest alone, okay? And so what we want to figure out is, okay, so how do I have 25 years to accumulate that balance? How do I do it? What sort of monthly deposits do I need to start making so that I can accumulate that in the next 25 years? I'm going to do this using the TVM solver. All right, so here's what we're going to do. So we need N, which is my total number of deposits. So here, I'm going to be making monthly deposits for 25 years. So the total number of deposits I'm going to make is 12 times 25. Which is 300 deposits. Okay, my interest rate is 7%. My present value, I haven't made any deposits yet, so that's 0. My payment, this is the thing I want to solve for. I'm trying to figure out what my monthly payments are going to be. My future value, that's the thing I just figured out. I know that by the end of this, I need it to be $714,285.71. All right, my payments per year, it's going to be 12. And my compounding per year is also going to be 12. All right, so let's take a look in our calculator at that. So apps, finance, TVM solver. And you can actually just have your calculator do the math right here. So you could really just put 12 times 25. I know I already computed it, but it'll do it for you. 7, present value is 0. Payment, I'll just leave it at whatever it is right now. So that's what I'm trying to solve for. Future value, that's my 714,285.71. Payments per year is 12. Compounding per year is 12. Now I want to do alpha enter on payment. And there we go. So I need to make payments of $881.76 per month. which may seem like a lot, but when you're an adult and you guys have a career job, that's totally doable. You got it, Naomi. You figured it out. Great. Anybody else having issues with their calculator or TVM solver? All right, let's continue on. The total return is the percent change in investment value. So total return is your accumulated balance minus your principal, so the original investment amount, divided by your principal times 100. All right, so this is a formula that you'll need. Give me a emoji hand when you're good. All right, annual return is the annual percentage yield that would give the same overall growth. So annual return is your accumulated balance divided by principal to the power of 1 over y minus 1. So this is just like, let's say you made some money from an investment in stocks. The annual return tells you basically what interest rate, if you put the money in a savings account, what interest rate would have earned you that same amount over some number of years. All right, again, just give me a hand when you're done with this slide. Okay. So let's do an example. You invest $3,000 in the Clearwater Mutual Fund over 4 years. Your investment grows to value to $8,400. What are your total and annual returns for the 4-year period? All right. Let's talk about total first. And so total return, remember, is just your accumulated minus the principal over the principal times 100. So my accumulated balance was 8,400 minus the 3,000, which was my principal, divided by 3,000 times 100. So what you end up with is 180% growth. So your total return was 180% growth. And your annual return, remember, just tells us what APR would you have to invest this in a savings account over those 4 years to get that same growth. Right, and that formula is your accumulated balance over your principal to the power of 1 over the number of years you're discussing minus 1. So,
Mr. Toller, you're muted.
Sorry about that. So total return, you saw me do it. Annual return, I'm using the second formula. So annual return, remember what it tells us is what we would have to, the APR at which we would have to invest this money in an account to earn the same amount over the given number of years. So I want to know, what kind of a savings account would I have to invest that $3,000 in to earn the $8,400 over 4 years? So my accumulated balance was $8,400. My principal was $3,000. I'm going to do this to the power of 1 over 4 and then minus 1. We'll do this pretty carefully in our calculator. 8,400 over 3,000 to the power, of 1 over 4 minus 1. So 0.294, you would need an interest rate of about 29.4% to have that same growth over 4 years. Which is very high. 180% growth is a pretty good return for a 4-year investment. Hold on one second. All right, we're going to stop there. And we'll pick this